Okay, class, picking up where we left off at. When we got this example here, it was PQRS intersect the null set. And I said the final answer was the null set. Well, let me draw that a little better than what I had it, or attempt to anyway. This is the null set, so that will be your final answer to this example. Now we come down here to this next example. It says find each of the following intersections. We have 7, 8, 9, 10, 11 intersect 6, 8, 10, 12. So we look here. The only things that they have in both is 8 and also 10. So our final answer here would be 8, 10. Now we come here to B, 1, 3, 5, 7, 9. We have 2, 4, 6, 8. If you notice here, we have an interesting situation where none are contained in either of these sets. So if we were to draw this as a Venn diagram, we know this will be a disjoint set because they have no common elements. So this answer here would be the null set. Now we have C. We have 1, 3, 5, 7, 9 intersect the null set. And we know based upon our previous example up here, anything intersect the null set is just a null set. Now, we have the union of sets. The union of two sets is the set of elements that are in either set or both sets. A union B means the elements that are in A or in B or both. When you see the union symbol, think OR. The union of sets A and B, written A union B, is the set of elements that are members of set A or of set B or of both sets. The union of sets A and B can be expressed in set builder notation as follows. This means that X is contained in A or X is contained in B with the A union B. So we have, if A is equal to 1, 2, 3, 4, 5, and B is equal to 2, 4, 6, 8, then A union B is 1, 2, 3, 4, 5, 6, and 8. Now if you notice, we did have some elements that are the same. We have 2 and 4, but you notice we only wrote those one time. So whenever you do the union, if you have elements that are the same in both sets, you only write it once. So now, example, if A is equal to 1, 2, 3, 4, 5, and C is equal to 1, 3, 5, 7, 9, find A union C. So we could put equals. Now, if you notice here, we have 1, 2, 3, 4, 5, and then in this set, we have also 7 and 9. So it'll be 1, 2, 3, 4, 5, 7, and also 9. And that is our final answer. Now we come to the next example. We have A, B, C, D, E, union C, D, E, F, G. Now if you notice, C, D, E is contained in both of these sets. So what we would do is this here. We will write A, B, and we'll write what matches up with them, which is C, D, and E. And we will also write F and G. So it's all of these elements. Now example, we have 1, 2, 3, and then we have our ellipse 15, 16, union 3, 6, 9, ellipse 21, and 24. So now if you look here, if you notice, this is going by ones and this is going by threes. So the first thing is this here. We know that all of this will be a part of the answer. So we know 1 through 16 will be part of the answer. So this right here is going to get, I would say, a bit lengthy, but this is how we could write this. We could go 1, 2, 3, and we can do our ellipse, comma, 15, 16, and then we can look here. Now we know that 15 is contained here. We know that 3, 6, 9, 12, and 15 is contained in both of these sets. But then after 15, of course, we have our 16, but the next number here would be 18, then 21, and 24. And that would be the final answer. So now we have our example, PQRS union the node set. Now with union, what would end up happening is your final answer would be the set that's union to the node set, which would be P, Q, R, and S. Now we scroll here to the next example. It says find each of the following unions. We have 7, 8, 9, 10, 11, union 6, 8, 10, 12. Now, let's start with the lowest number. Well, it really doesn't matter the order, but I just like to put it in order. So we have 6, 7, 8, 10, 11, and also 12. Now this contains all of these elements. So we have our 6, 7, 8, 9, 10, 11, and 12. Now we have 1, 3, 5, 7, 9, union 2, 4, 6, 8. So we will have 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is our final answer. Now, we have the set 1, 3, 5, 7, 9, union the null set or empty set. And we know our final answer would be the set that's union to the empty set. And that is our final answer. Now, it says the empty set and intersection and union. For any set A, we have A intersect the empty set or null set, it equals the empty set. A union the empty set is equal to A. Given, we have U is equal to 1 through 10, A is equal to 1, 3, 7, 9, and B is equal to 3, 7, 8, 10. So now, we have A intersect B. So we look here. The only elements that they have in common is 3 and 7. So our answer here would be 3, 7. Now, it says find A union B complement. So what we need to do is look at all the elements of A and B. Now we can go off to the side and write all of the elements of A and B. We have 1, 3, 7, 8, 9, and also 10. Okay, these are all the elements of A union B, but we need to do the complement of that. The complement is all of the other numbers. So we look up here and our union, well, yeah, it's not the union. We're looking at our universal set. Okay, so when we look at our universal set here, we have 1, 3, 7, 8, 9, 10. So what we need to do is pick out all the numbers that are not these numbers here. So we will have 2, we will have 4, we will have 5, 6, and that is actually it. We will stop at 6. Because remember, the complement means basically all of the values that you do not have that's contained in this set here. So now it says find A complement intersect the B complement. So what we need to do, let's write what our A complement is, and then also our B complement. We have A is 1, 3, 7, 9. So A complement would be 2, 4, 5, 6, 8, and 10. That would be our A complement. Now we would do our B complement. B complement, you notice we have 3, 7, 8, 9. So that would be 1, 2, 4, 5, 6, and finally 9. So now we want to intersect these. We have 2 in common. We have 4 in common. 5 and 6. So it's 2, 4, 5, and 6. So A complement intersect B complement is 2, 4, 5, and 6. And that is the final answer. Now, we scroll down here to this example. Given the universal set is 1 through 9, A is 1 through 5, and B is 1, 3, 6, 9. It says find A intersect B. Now, if you notice here, we have 1s in common and we have 3 in common. So the intersect of A and B is 1, 3. Now, we have A union B, complement. So we have 1 through 5, 6, and 9. So what we would need to do is this here. We know that it will be all of these digits plus 6 and 9. So A union B complement would be the numbers contained in the universal set that are not these numbers. So we would look at 7 and 8. And that is the complement. Now we have A complement intersect B complement. Now we look here at the A complement. So A complement would be 6, 7, 8, 9. The B complement would be 2, 4, 5, 7, and 8. Now we want to intersect this here. The only thing, they only have 2 values that are the same, which is 7 and 8. So our answer here would be 7 and 8. And that is it for that example. Now we have example. It says given. We have this Venn diagram here. And now we want to find A intersects C. I had to move this graph down here. But let's take a look at A intersects C. When we look here, the only place that A and C intersect is at 1, 3, and 5. Now, we have A intersects C complement. Now we look here. A intersects C, we know is 1, 3, 5. So that means that the complement is everything else, which we would have 2, 4. We would take this 6, 7, 8, and also 9. Remember, the complement means everything else is not in this set. So now we have A complement union C. So the complement of A would be 7, 9, 6, 8. So let's do that. Let's write that out. I know I wrote it out of order, but that's fine. And we want to union this with C. Now C is 1, 3, 5, 7, 9. Now we want to union these here. So we know that our final answer is 1, 3, 5, 6, 7, 8, 9. And this is our final answer. Now, we have find A complement intersects C complement. Now, we know that A complement was 7, 9, 6, 8. C complement is 2, 4, 6, 8, which we can see here. So now, what they have in common is 6 and 8. So this answer here would be 6 and 8.